right? Back when I had more time and less money, whenever I bought a new hard drive, there's always a sweet spot where like the gigabytes per dollar is the best, right? And if you buy like too small of a hard drive, you're a loser because you have a small hard drive and because you paid too much for it, right, per gig. But if you know, back in the day, if you needed like a terabyte hard drive, it cost more per gigabyte than your 320 meg, right? It turns out computers work the same way, even when you're buying them at the scale that we're buying them at, where there's sort of a sweet spot for servers where you get the most processing bang for your buck. And if you're below that, you're a loser because you got a crappy computer and no processing power out of it. And if you're above that, you're paying more per flop, or megaflop, or teraflop, or however you want to measure it. So if you think about this, what ends up happening is you get to a point where you have to buy really expensive hardware if you're scaling up to keep up with how well your company is doing, right? So we got to that point, and we're sort of, people are weighing what we should do with it. And what came out was, look, if we could actually just buy a bunch of these little crappy computers and somehow glue them together with magic fairy dust, and then we'd get the right price point, and we'd also know when we needed to double capacity exactly how much it was going to cost. You no longer have this sort of weird curve that you're trying to figure out. So one of the ways we backed into this sort of big data situation was having too much data to be able to manipulate. And so this is the second part I want to talk about, which is what we actually do with it, right? And there's sort of two large classes of stuff. One is making sure that the processes that we were running before still work. And billing people that we have to bill, making sure what our numbers actually look like. These are processes that have been running for, we're 11 years old now, something like that, for a long time, right? And we've got reasonable numbers out of it. But they were based in technologies that had different characteristics than the big data stuff these days does, right? It turns out if you want to parallelize something, you have different constraints on what you're trying to do. So that's sort of one class of problems which are interesting to engineers because it's sort of like a puzzle you get to figure out. Like, how do I do this without doing an outer join, right? Which is the sort of thing that gets engineers up in the morning. There's another whole class of problems, which are the ones I've had the opportunity to work on relatively recently, which is we have a lot of data. And whenever you have a lot of data, everybody's eyes light up and they're like, well, you should do analysis on it because then you'll get more money out of it. And nobody really knows what they're talking about when they say this. But the idea is that there's a big pile of data, and there's gold in there somewhere, right? And if you only knew the magical incantation to find the gold, you'd be in better shape than you are today. And it turns out that predictive analytics are in fact the gold. Or at least they're the pick you need to get at the gold. Because what we're doing these days, I'm trying to think of how to say this in a way that doesn't get me in trouble. What we're doing is we have a lot of user data, right? And so what we want to do is show people a great experience on the website. And what it means to have a great experience is that when you get up to TripAdvisor, we help you find the right hotel that delights you, right? Not like the Four Seasons down the street that everybody stays at, but like that little cool place that is just what you're looking for. We've got a lot of people coming to the site. And a lot of them are finding those hotels. And so if you stumble across one that's close to what you're looking for, if we could tell you what other people went and found, maybe that would get you to where you want it to be, right? And so looking at this aggregate browsing behavior of the people on the site turns out to be really useful to our customers and actually turns into cash at the end of the way. And so, if you're making something like $1 million and you lift up by about 1%, right? You've got some real cash. I mean, like, embarrassingly large amounts of cash. But you can't do it unless you can churn over that data fast enough to actually generate the results in not real time, but they get stale fast enough that you have to keep up with it. So that's one of the big uses of Hadoop right now that I'm sort of deeply involved with. And what's really cool about it is two things. One, having spent about 2 years working on social media, it's really nice to be making money for the company. Really, that's not funny? That's hilarious to me. And two, there's a lot of really interesting research in this space, right? People are doing cluster analysis for a long time. People have been doing all this there's this cool stuff with like, invariant hash set analysis. And all of it is really hard to do in Hadoop, right? You guys know what I mean, right? It's just, as soon as you sort of hit this wall where you're like, I didn't partition my data that way, and then you're screwed, right? So there's a sort of an interesting technical challenge, and when you get through the interesting technical challenge, money falls out of the end. And this is like engineering nirvana, right? Because doing math and money comes out, it shuts up all the, probably MBAs in the room, but it shuts up all the MBAs that think that their stuff matters, because what matters is math. What matters is math on user data that you've actually gotten off the site, not modeling, and not making stuff up and using intuition. Intuition gets you like 10% of the way there, and then it's wrong, right? What you want to do is look at the data, but the data is so large that you have to use the right tools for it. The second thing is that there's this guy named Peter Norvig who's like chief smart guy at Google. I don't know what his real title is. But a buddy of mine at TripAdvisor ran across his blog and he sent it to me. He's like, this guy seems really smart. We should try to hire him. If you guys don't know who Peter Norvig is, it's not fun. But if one of the things he talked about a year and a half ago was more data beats better algorithms. Right? Have you heard this meme? Which is sort of, to first order, if you can get more orthogonal data into the system with which you are making decisions, you can apply relatively brain-dead algorithmic techniques to it and do better than the really smart guy. So most of my life I've spent in startups. This is actually my first real job, and I'm like 40. So my parents are delighted that I finally have come out of the woods. And all of the startups I had sort of small sets of data. And what do you do when you have small sets of data? You apply the most fancy algorithm. You're like shoveling around this tiny little pile of data, trying to get something out of it, and there's nothing there. What you need is a lot of data. Once you have a lot of data, and this is where the world sort of works out to our advantage, you can actually apply some of the brain-dead techniques that Hadoop is actually able to do and get really useful answers out of it. You don't have to do the really complicated stuff, which is good, because you can't, right? Or at least it's very hard, or it doesn't play, I'll be nice, it doesn't play to the strengths of the tools that we currently have, right? And it kind of works out for you. And Google has gone and made a ton of bank on this by solving a collection of problems that people find valuable, which are, and I forget which one of the Troika said this, are embarrassingly parallelizable, right? Which is a really cool way to sort of look at the world. If you can find those sorts of problems, then now all of us have the tools to go and exploit that. And that is way, way cool. The last thing I want to talk about real quick is sort of, I got dropped into working with this stuff about 3 months ago, a quarter ago, and sort of directly into the deep end. And I learned a couple of things, and if you're just getting started with this stuff, I thought I'd share it mostly so that when you're terrified by the same stuff I was terrified by, you'd have company. Number one, this stuff feels different in the same way that a really different language feels different. And I'm not talking about going from like Python to Ruby, whatever, right? That's like, I can write a syntax convert on that. I'm talking about going from like Ruby to like, I don't know, Haskell or OCaml or one of these crazy things. You're going from like, Java to Lisp, right? It feels fundamentally different. And what you'll do for the first little while is you'll write all of this stuff such that it smells like the old mindset that you had, and you'll keep trying to coerce it into that environment. And one of the things I found is that as soon as people find Hive, they're like, oh, it's SQL. And it's really not. I mean, it sort of looks like it, but it has like landmines lying around that when you stumble across, you're like, why did everything suddenly grind to a halt? And unless you understand what's actually going on underneath the surface, you can't avoid them. You don't even know they're there, right? So thing one is it's harder than it looks to start out with, but it's also kind of fun because it's a class of problems that you can see that sort of blue lines around. Number two is I'm a little old school. I actually saw the Star Wars movie in the theater, right? So I'm used to the command line, and Hadoop works in browser windows. And it updates beautifully in these browser windows, and I sit there with the browser window like minimized, and I stare at my console, and there's nothing there. I don't know how to fix that, but God, I wish there was a command line option that I could just see stuff scrolling up. I understand it's harder to do, but there's something different. In the same way, if you've always done server-side engineering and someone asks you to write JavaScript in the browser, right? You're sitting there staring at it, wondering, well, where's the command line? Where do I fiddle with this? How does this actually work? I don't even know what the runtime environment smells like. It's the same sort of discontinuity that you have to get through. Number three is, the old joke is if you have a hammer, everything looks like a nail. Everything really isn't a nail to do. It is not the right tool for sort of online analytics, right? Hadoop is like a dinosaur, right? In a good way, like a big, beefy, angry dinosaur that you like start up and start walking in. It's going to crush everything in its path to get to the answer, but it takes a while to get moving. And if what you need is 15 millisecond response time on a web service, it is absolutely the wrong tool for you. What you should do is go and pre-process every possible answer, okay? And then have a ginormous chunk of RAM that you store that away in, and then you've got what you need. But don't expect Hadoop to have that sort of responsiveness, because it's just not the right tool for the job. And I'm waiting for the moment when everybody starts applying it everywhere. The same way, like JavaScript started out in sort of one space, and now it's invaded everything. And in JavaScript, it's sort of okay. I can live with it. With Hadoop, it's really the wrong tool for the job. But this leads me to point 4, which is that debugging stuff takes a slightly different mindset, right? Because you're starting up this large chunk of machinery, it's not sort of, let me write a little bit of code, fiddle with it, write a little bit more code, fiddle with it, which is sort of, maybe I'm the only person that works that way, but it's incremental development like that. Your fiddle cycle is like 10 minutes, which is enough for me to lose interest, right? I wander off and I grab a coffee and I come back and I don't know what I was working on. And I don't, the best answer I found to this is start with small data sets, real data sets with small data sets, and then scale them up to whatever else you want to use. And the last thing is, I've been programming for 1 million years, and this feels different and fun in a way that few new technologies have. Most new technologies are sort of old technologies with a new hat, right? This one is different, and it's different in a way that I find very enjoyable.